Hello guys, this is Dr. Possibility from Excel Academy. Kindly make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. In this tutorial, I'm just going to do my organic chemistry on the nomenclature of alkenes. So when we talk about alkenes, these are just organic molecules that have at least one double bond. So alkenes, these are just organic molecules that have at least one double bond. So let's quickly look at some rules which you're supposed to follow when you're trying to name these alkenes. So when you talk of the nomenclature of alkenes, the first thing that you need to consider is step 1. So when you talk of step 1, you need to make sure that you name the parent hydrocarbon. So you should be able to identify the parent hydrocarbon. So how can you identify the parent hydrocarbon? So you can simply identify the parent hydrocarbon by finding the longest carbon chain which is containing the double bond. By finding the longest carbon chain which is having the double bond. So that should be the first step. So let's quickly look at the example. So I have this example. So some of you who try to identify the longest carbon chain by going or using this route. Let's say you go that route, then that, and then that. Okay, and others would go this way. So you go that way, and that way, and then you go that way. So the question is, between these two guys, the first guy and the second guy, between these two, which one is correct, or which one is the best route for one to use when you talk about the identifying the parent chain? So if you look at this guy, he has moved from 1, 2, 3, 4, 5. Okay, then there is this guy who has moved 1, 2, 3, 4, 5, 6. Okay, in a normal circumstance, the second one seems to have more carbon than the other one. Okay, but according to the rules here, the rule is that find the longest carbon chain containing what? The C double bond. So if you look at one is simply what? The first one is simply correct, and the second one is simply what? Wrong. So take note of that. The first one is correct. Why is it correct? Because the longest carbon chain is having a double bond. But when you talk of the second one, it is not going toward the what? Is not going toward the double bond. Okay, so with that in mind, because we have how many carbons in the first one? We have 1, 2, 3, 4, 5. So since we have 5 of them, remember we have 1, 2, 3, 4, 5. So since we have 5 carbons in this chain, so this guy is said to be what? To be pentene. Okay, 5 it just simply means pentene. And in this writing, you can discover that there is a ENE. So ENE is just simply telling us there is a double bond and this is an alkene. So some people, those who use the wrong route, they might have named this one as hexene because it is having what? 6 carbons in it. So the first one is correct. The second one is what? Is totally wrong. The reason I've already stated. The first one is considering the double bond, whereas the second one is not considering the double bond. Okay, let's quickly look at the next step, or something that we need to know. So step 2. So the first step, let me go back. You identify the parent chain. You identify the parent chain. You consider the longest carbon chain, which is having what? The C double bond. So let's quickly move on and look at step 2. So step 2, you need to number the C atoms in the chain. Okay, if you look at this one, we just counted. Okay, here we just counted. We simply said 1 2 3 4 5 6. Okay, and someone said hexene, which was wrong. Here we also said 1 2 3 4 5. Okay, and it was pentene, which is the correct one. So here we have just we have just identified. But the next thing we need to know is that how can you number this this molecule? Are you going to start from here, or are you going to start from the other side? So this is where step 2 comes in. So step 2, you number the C atoms in the chain. So you don't just number them. Instead, you follow a certain rule. So you need to begin at the end, nearer to the what? To the CC double bond. So you need to start from the end, which is nearer to the what? To the double bond. So if the double bond is at the same distance from the two ends, begin at the end nearer to the first branch point. So there are some molecules that have branches. There are some molecules that have branches, and when you consider that, you find that maybe the distance between the two ends is just the same. So when the distance is the same, you need to apply the what? You need to apply the third rule, which is you need to consider the end which is nearer to the what? To the first branch. So let's quickly look at this guy here. So if we have this guy as our molecule, so we need to consider which side are we going to start from. Are we starting from this side, or are we starting from the other side? So we need to look at which side is nearer to the what? To the double bond. Okay, so there, because this side is nearer to the double bond, so we can start this as 1, then the other one as a 2, then we have a 3, we have a 4, we have a 5, we have a what? We have a 6. Okay, and then in a case like this one, if you look at the double bond, the point from this side to this side, you find that there are 1 2 3 1 2 3. Even if you go that way, 1 2 3, so they are just 3. So the parent chain from this side, it's having 3, and then you go this side, 1 2 3, so they are also 3. So the distance from here to there and the distance from there to there is just the same. So when it comes to numbering, that's where you are now going to consider the point whereby you consider the side which is having the first branch. So if you look at this side there is no branch, isn't it? This side there is no branch, but this side there is a branch. So you can consider this one as a branch, which is a methyl group, or that one as a branch, but in that case I've utilized this one as a branch. So the naming will start from here, which will be 1 that one, 2 that one, 3 that one, 4 5 and 6. So this should be your second step when you are naming the alkenes. So make sure that the CC get the lowest possible number. So make sure that this bond has the lowest possible number. Okay, we move. Remember, we had the first step, which was identifying the parent chain and naming it. Then we had to consider the second step, which is numbering the C atoms in the chain. Okay, let's quickly move on and look at what's next. So the next one is step 3. So when you look at step 3, what you need to consider is to write the full name. Okay, remember, you identified the parent chain. Now you identified the parent chain, then you had to number them, and then now you need to write the full name. Okay, so as you write the full name, you need to consider the number, okay, by numbering the substituents according to their position in the chain and list them alphabetically. Okay, there is a very important point which we have outlined, which is number the what? The substituents. So these substituents are the branches that might have existed in that particular molecule. Okay, so with that being said, let's say we talk about this guy here. So we have this guy which I've already mentioned there. So this is what? 2-hexene. So the 2 which is in front here is talking about the what? The number, the carbon at which the double bond is existing. Okay, look, let's go back. The first one we did was to identify the what? We identified the numbering. Okay, we identified the numbering. So when we did the numbering, when naming, we need to consider where the double bond is what? Is existing. So for example, in this case, the same example we gave. So if you look at that guy, you need to understand that this is what? 2-hexene. This is 2-hexene. This 2 here is coming from that numbering which we did in step 1, in step 2. Or this can be said to be what? Hex2-ene. So there are people who are used with writing like that, and there are those who are used with writing like that. Personally, I prefer using the first one and not the second one, but either is just okay. Okay, then let's quickly look at the other one. Remember, I gave 2 examples here. The first example I gave was for this guy here, and then there is also this one whereby there is a branch somewhere there which is just the substituent. Okay, so you have written the full name, which is that one, 2-hexene or Hex2-ene. Hex2-ene. Remember the last all the alkenes, they end with ene, like I stated. So we have the next one, which is this one. We have already numbered them, which is 1, 2, 3, 4, 5, 6. So what could be the name of this molecule? So this molecule will be 2-methyl. So this 2, it is the position of the what? Of the substituent. Okay, the first branch. So the first branch was a methyl group. So because it is a methyl group, you are going to say 2-methyl. This 2 is talking about the position. Okay, so the first thing you're going to do is identify the what? The parent chain. So the parent chain was hexene. Okay, so this being hexene as the parent chain, you now need to identify the what? The position where the first branch is. So the branch is on position number 2. So you're going to say 2-methyl, because this is a methyl group. Okay, this is a methyl group. So you're going to say 2-methyl, and then you attach the name. Okay, you say 3-hexene. This 3 is talking about where the bond is, the double bond is. Or this can be written as 2-methyl Hex3-ene. So you can either write it in that way or the other way, but like I've stated, I normally prefer using the first way. Let me repeat the same thing. Writing the full name. 1, when you number them like that, after numbering, you need to do what? You need to also know where the branch is. So in this case, the branch which is a methyl group is on 2. You write that 2, then you say methyl, then 3 to show where the double bond is, and then hexene, like that. Okay, guys. So we can look at this guy. We can look at this guy, and you can give the name to this guy. So how can you give the name to this guy? So So you identify the parent chain, which is that one. I hope you guys can remember. The parent chain should have a lot of carbons, isn't it? And in that parent chain, there should be a double bond. So we are going to move 1, 2, 3, 4, 5, 6. You can go 7 like that or 7 like that. So let's quickly start with the first step, which is identifying the parent chain, which I've now identified there. Then after identifying the parent chain, you do what? You number them. So when numbering, you start from the one which is closer to the double bond. So you have 1, 2, 3. Then this side we have 1, 2, 3, 4. So we are going to start from 1, 2, 3. So we are going to have 1, 2, 3. Then there are 4, 5, 6, 7. Remember, the numbering will help us to know where the branch is, and also to know where the double bond is. Then remember, after you identify the chain, after identifying the chain, what are we also supposed to identify are the branches? So in this case, this is very easy. We have the methyl group there, the methyl group there, and then the methyl group there. So we have 3 methyl groups. So what could be the name? The first thing, like we have stated, we have 3-heptene, okay? 3-heptene. So 3-heptene, remember it has 7 carbon chain, and then this 3 is talking about the what? It's talking about where the double bond is. So this name 3-heptene is just the name from 1, 2, 3, 4, 5, 6, 7 without considering the branches. But that's not the name, okay, of this molecule. Then you consider the 3 methyl groups. Remember, we have, let me repeat that a bit for you to understand. The first one is 3-methyl. The first one is 3-methyl. 3 talking about the position, which is a 3. Then the second one is what? 4-methyl, okay? 4-methyl talking about where it is. And then you have 6-methyl. So we have identified 1. We have identified the chain there in green, which is 3-heptene, 3 where the double bond is. Then 3-methyl, this one where the first methyl group is, the second methyl is on 4, and the last one is on 6. So that's where now the name comes in. Remember, let me repeat that. You have 1, 2, 3, okay, with their position, and then everything here will come together to create that name. So the name is 3, 4, 6. 3 to show where the position of the first methyl group is. Then you have 4 where the second methyl is. Then 6 where the third methyl is. Because there are 3 methyl groups, you're going to say trimethyl. And then 3-heptene. Okay. So guys, please make sure that you subscribe to our YouTube video. Make sure that you share this video to your friends and anyone whom you know that they are doing organic chemistry. Okay guys, let's quickly look at this one. This is a very interesting molecule. So the first step, like I've stated, identify the what? The parent chain. So if you look at this, we have 1, 2, 3, 4, 5, 6, 7, 8. So if you use this route, you are wrong. If you use this route, you are wrong. Then we have the other route, which is 1, 2, 3, 4, 5, 6, 7. So if you look at this route is having 7. The other route is having 8. So if you go with the route which is having 8, you are totally what? You are totally wrong. Reason being is that this one is not having a double bond, but the other one is the one which is having a double bond. So that route is totally what? Is totally wrong. Okay, that route is totally wrong. So if you use that route, then you are wrong and you'll be considered to not knowing how to name them. Okay, so it's not as octene, because octene is the one which has 8 carbon molecules, so you don't have to move in that way. So which way can you use? Like I've already explained, you're going to move that route. So this route is 100% correct, and it's the route which you are expected to move. So you have 1 2 3 4 5 6 7, and this is the correct route, and this is known as what? 1-heptene. This one is just talking about the position of the double bond. So the position of the double bond is on carbon number 1. Okay, so when we do that, we can consider the branch. So that branch, it is ethyl. That branch is ethyl, and the position is on carbon number 2. So it's going to be 2-ethyl. So with that in mind, the overall name will simply be 2-ethyl 1-heptene. 2-ethyl 1-heptene. So that's the correct name for that organic molecule. Alright guys, we can now move on and look at another example. So let's quickly look at this example. How can you know which one is the correct route of the parent chain and which one is the wrong route of the parent chain? So that's that one. 1 2 3 4 5 6 is the what is the correct route, which is just hexene, okay? So if you move this other way, then you are wrong. So you need to move the one which is having the what? The double bond. Then let's quickly identify the branches. So we have 2-methyl, then we have another 5-methyl, then we have isopropyl. So we have 3 isopropyl. So what will be the name? So the name will be 3-isopropyl 2,5-dimethyl. Okay, so we need to arrange the branches according to the what? To the alphabetical order. So in this case, you need to know that I starts before M. So before you have M, which is coming from methyl, there is I. So some people might get confused and try to start with dimethyl, then you are wrong. So you need to start with the one which starts first in terms of the alphabetical order. So I starts before M. That's why we have started with isopropyl. We are not considering di. Di is just telling us that there are 2 methyl group in this particular molecule. So this is the name of this organic molecule which I have given. Okay, so ladies and gentlemen, we also have cycloalkenes. So cycloalkenes, these are just alkenes that exist in circular form or in a ring form. Okay, so the cycloalkenes are named similar as acyclic alkenes. So acyclic alkenes are the ones which I've just given, but the cycloalkenes, so that you need to make sure that the C bond is between C1 and C2. So as you number the cycloalkenes, you need to make sure that the double bond is between C1 and what? And the C2. Okay, and this should be according to where the branch is. Okay, by making sure that the branch is having the lowest number. So let me quickly look at example. So I have this one, I have this guy there. So you need to number 1 there, 2 there, 3 there, 4 there, 5 there. So if you look at the double bond which is here, I've put it between 1 and 2. 1 and the 2. So the double bond need to be between 1 and 2. And this one need to be closer to where the branch is. So with that in mind, this will be 1-methyl one methyl, it is the branch, the branch here. So the branch here is 1 methyl cyclohexene, because this is what a ring structure with 6 carbons in it. Okay, so if there is only one double bond, no need to indicate the position of the double bond. Take note of that. If there is one double bond, there is no need for you to indicate the position of the double bond. You can only indicate the position of the double bond if you discover that there are more than one double bond in that molecule. Okay, let's quickly move on and look at the same cycloalkenes. Remember, this point is just the same thing that I've already explained. Okay, so we have another example here. So how can you number? So like I've said, the numbering should be between what? Should be between 1 and 2. 1 and 2. Okay. So in that case, you start 1 there, 2 there, 3 there, 4 there, 5 there, and 6 there. Okay. So that one will be 1, 4. Remember, this methyl group is on carbon number 4 there. So you have 1, 2, 3, 4. So this will be 1, 4 dimethyl cyclo. Cyclo means it is a ring structure. Cyclohexene. Okay. Let's quickly look at this one. So this one will be 1 there, 2 there, 3 there, 4 there, 5 there. And then the name will simply 1, 5 dimethyl cyclohexene. So that's the name. Okay, we're still on this guy. So sorry for the poor drawing there. So in this case, this guy will be 1, 2, 3, 4, like that. And then this will just be cyclobutene, because there are 4 carbons in the ring structure, and then 1 methyl there, another methyl there, and the name is 1, 3 dimethyl cyclobutene. So guys, these things are not hard. The only way you can know these guys is just by following these simple rules. Okay, let's quickly look at this one now. So this one, if you look at this one, you need to understand that this guy is having more carbon chain, and is the one which is having the double bond. Okay, this one, if you look at this one doesn't have a double bond, but this one which is outside is the one which is having a double bond. In such a case, there are some rules that you have to follow, such that you don't have to get this one as your main guy. Instead, you need to get this one with a double bond. If you look at the previous examples, the double bond was in the what? In the ring, but this time around the double bond is outside the ring. That means that the main or the parent carbon chain is the one which is outside, and this ring becomes the what? Becomes the branch. So in this case, we'll start with this one as 1, that one as 2, and that one as 3. And when there are 3 carbons, that's a propene, and then that one is just a cyclopropyl. 3 cyclopropyl. 3 is coming from the fact that we have what? This guy is on the 3rd carbon, so the name is just 3 cyclopropyl propene. 3 cyclopropyl propene. So that's the name of this molecule. Okay, there's another part of naming these guys. So this has to do with the cis and trans isomerism. Remember, there is a double bond. There are some double bond here. So it being a double bond, that means that it's able to produce 2 isomers, and there are type of isomers which can be E and Z, and also cis and the trans isomerism. So in this case, there is an issue of making sure that you are able to follow the first priority, the second priority. So such things of priorities, I'm going to share a video on that particular subject. So this guy is restricted, the rotation is restricted because of the double bond which is there. So the double bond which is there, it causes the restriction in terms of the rotation of the carbon to carbon bond. Okay, then two different atoms or group of atom attached to each of the carbon atom which forms the double bond. So I'll show that later. So if you look at this one, there is this guy here and that guy there, isn't it? So this guy and that guy, they are participating in the double bond, but amongst them they have these molecules. In this case, you have a molecule which is hydrogen. So this guy hydrogen there and that hydrogen there, they have attached themselves to this carbon atom. So the orientation differs. You find that maybe this one is up and then that one is down. So in such a case, this leads to the naming of these guys. Okay, this leads to the naming of these guys. So let's quickly look at this example. So we have this example which this is a 2-butene. This is a 2-butene. So this 2-butene can have two structures. The first structure is this one. So if you look at the first structure, this group which has the higher priority and that group with higher priority, they are the same guys. But because they are the same guys, you need to understand that they are on opposite direction. So this one is that side, that one is that side. So this is known as a trans 2-butene. This word trans is coming from the fact that they are on opposite sides. So when they are on opposite side, you give the name as trans. So trans butene. So trans 2-butene. So this name is coming, 2-butene is coming from the basic which I've already given. The trans has come in because of the positioning of the molecules. Another way in which this butene can exist because of the double bond, it is in this way. So in this way, you need to look at the ones with higher priorities are on what? On one side, and also these guys are on one side. So in such a case, this will be cis. So same side, it is cis, different sides, it is what? Trans. So two groups on the same side, like I have said, it is known as cis, and two groups on opposite side is known as trans. Alright guys, thank you very much for joining me. In case you want to get in touch with us, you can simply contact us on the numbers which I am sharing on the screen. Thank you very much guys. This was Dr. Possibility from Excel Academy.